Good day to you once again. You are welcome back to Organic Chemistry 2. We have been discussing various families. I told you we have alkane, alkene, alkyne, alkanol, alkanal, alkanoic acid, alkanoate. We've been discussing alkanoate for some time now. And while discussing alkanoate, we took ethyl ethanoate as an example. And I told us there is a need for you to differentiate between the general formula and general molecular formula. For alkanoate, we have RCOOR prime. And I told us you can rewrite it this way. R is the alkyl group, that's CnH2n plus 1, COO, CnH2n plus 1. CnH2n plus 1 is the alkyl group. And in naming it, you name first from the right. All that was discussed earlier, of which I will not go back to. I talked about esterification, which talks about an alkanol reacting with alkanoic acid to give alkanoate. So straight away, I just want to mention the physical properties and chemical properties of ethyl ethanoate. We have the physical properties here. Number one, it's a colorless, volatile liquid with a pleasant smell. A colorless, volatile liquid with a pleasant smell. I told us pleasant smell is a physical property. So if you are asked to mention a physical property that distinguishes alkanoate from all other organic compounds, the answer is pleasant smell. Number two, it is slightly soluble in water. Alkanoate, specifically ethyl ethanoate, is slightly soluble in water and it has a boiling point of 75 degrees Celsius. I'll quickly move on to the chemical properties. If you remember, I did say earlier that it is the functional group that determines the chemical properties of a compound. So, and when you have RCOR, once you remove the first alkyl, just remove the first alkyl, you'll be left with the functional group. And the functional group of alkanoate is written as such. You can write it this way, or you write it the way that will give you the mark. Remember I said 4 bonds must join to a carbon, 1, 2, 3, 4. So it can be written this way or this way. Either way, you'll be given the mark. So chemical properties now. Number one, hydrolysis. Addition of water gives back the component ethyl ethanoate. When you add water to ethyl ethanoate, you will get the component of ethyl ethanoate. So when water is added, you will have ethanoic acid. Remember, I said you should always count the number of carbons to give you an idea. So you have 2 carbon atoms here. And under alkane series, it is ethane that has 2 carbon atoms. So this is ethanoic acid. Why is it ethanoic acid? The functional group here is COOH, the carboxyl group. So we are talking about alkanoic acid there. So you have the COOH. Since it has 2 carbon atoms, so that will be ethanoic acid plus ethanol. You realize that the functional group is OH. The functional group for alkanol is hydroxyl group OH. So you have 2 carbon here. You ask yourself again, which alkane has 2 carbon atoms? That's ethane. So you have ethyl and alcohol, ethanol. So when you react ethyl ethanoate with water, you will get back the component element, which is ethanoic acid and ethanol. Maybe I'll give 1 or 2 other examples on that very briefly. Let me ask, I want to get back the component element of butyl propanoate. The The first thing is to write butyl propanoate. Now, since it is propanoate, it means the remaining carbon atoms there must be 3. So I'll write C2H5COO. I said butyl, so butyl is C4H9. This is butyl, C4H9. The remaining carbon atoms here is 3, so that makes it butyl propanoate. And if you remember also, I said the OH is removed from the alkanol. So this is butanol, and the H is also removed from the acid. So the component element of butyl propanoate is butanol and propanoic acid. That's the simplest way of knowing it. The component element of butyl propanoate is butanol and propanoic acid. Let me give another example. Maybe okay, if I write C4H9COO C2H5, that is ethyl. How many carbon atoms do we have left? 5. Ethyl 1 plus 4 making 5. So that would be ethyl pentanoate. So what are the component elements of ethyl pentanoate? If you remember, I said just remove your the OH is always removed from the ethanol, and you have the H. Remember, water will be removed. So the component element will be ethanol and pentanoic acid. In a nutshell, ethanol and pentanoic acid. So that's that about that. Hydrolysis. Addition of water gives back the component element. So for ethyl ethanoate, which has been said earlier, I could just assume the OH is here and the H is here. So the component element will be ethanol and ethanoic acid. So that's just an idea. Number 2, reaction with ammonia. Reaction with ammonia. When ethyl ethanoate reacts with ammonia, it gives you ethanol and ethanamide. When ethyl ethanoate reacts with ammonia, it gives you ethanol and ethanamide. So you have the equation here: ethyl ethanoate reacting with ammonia to give you ethanol and ethanamide. When you look at this again, when you look at this again, how many carbon atoms? 2. Which alkane has 2 carbon atoms? Ethane. And we are discussing amides. So ethanamide. If I write C3H7CONH2, C3H7CONH2, what do you think the name will be? C3H7 is an alkyl, which is propyl, but there's an additional carbon making 4. So this will be butanamide. If I write C4H9CONH2, what do you think the name will be? You check how many carbon atoms do we have altogether. That's 5. So that will be pentanamide. And on. Don't forget the functional group is this. Once you remove the alkyl group, you have the functional group. So let me just move on. So like I said, when ammonia reacts with ethyl ethanoate, you get ethanol and ethanamide. Number 3, reduction. Reduction. Ethyl ethanoate is reduced to ethanol by hydrogen, using lithium tetrahydroaluminate 3. That's a good reducing agent. Reduction of ethyl ethanoate gives ethanol by the addition of the hydrogen, which is from lithium tetrahydroaluminate 3. From the IUPAC, which I just said, maybe I should give an hint. From the IUPAC, which I just said, what do you think the oxidation number of aluminium will be? From the word lithium tetrahydroaluminate 3. That tells you oxygen number of aluminum there is +3. Let's check it out. You have lithium, you have your aluminum, and you have your hydrogen. Now in this case, lithium is plus. This is an exceptional state for hydrogen. Most times hydrogen will have +1. Remember, when an atom loses electron, it becomes positively charged. When it gains, it becomes negatively charged. Here, and that's why hydrogen can behave as a group 1 or group 7 element. It can behave as group 1 by losing 1 electron. It can behave as group 7 by gaining 1 electron. So here, because it must be balanced, hydrogen here is minus. You are looking for aluminum, for instance. So this is +1 plus the X you are looking for. This minus times 4, that's -4, equals to 0. So you have X minus 3 equals to 0, so X equals to +3. So in this case, the oxidation number of aluminum is +3. I've just digressed a bit. So you have hydrogen as -1 here. So that's how to name the compound lithium tetrahydroaluminate 3. So it's a good reducing agent. It reduces ethyl ethanoate to ethanol. What are the uses? Generally, it can be used as solvents. That's number 1. Number 2, it can be used in perfumes and cosmetics. And thirdly, it can be used as an artificial flavoring for food. Those are the few uses of esters generally. So I'm going to move on straight away to another subtopic. I'm going to move on straight away to another subtopic. And that topic is fats and oil. Fats and oil. We need to know the difference between fats and oils. Basically, they are known as lipids. Basically, fats and oil are known as lipids. They are generally known as lipids. And you should know fats are solids, oils are liquids. That's the basic difference between the two. Fats are solid, they are solids, while oils are liquids. Both are esters of trihydric alkanol. Both are esters of trihydric alkanol. If you remember your organic chemistry 1 very well, we have monohydric, we have dihydric, and we have trihydric alkanol. Any compound with 1 hydroxyl group is monohydric alkanol. Any one that has 2 hydroxyl group is dihydric, and anyone that has 3 is trihydric. So we have the general ones like ethanol, butanol, propanol, hexanol. They are all monohydric alkanols. They are all given. If you have an alkyl like C2H5OH, it has 1 hydroxyl group, so it's a monohydric alkanol. You have C3H7OH, it has 1 hydroxyl group, so it's a monohydric alkanol. You have C4H9OH, it has 1 hydroxyl group, it's a monohydric alkanol. But we have ethane 1,2-diol, ethane 1,2-diol, which is a dihydric alkanol, and we can have propane 1,2,3-triol. Propane 1,2,3-triol is a trihydric alkanol, and the common name of propane 1,2,3-triol is glycerol. So when you have propane 1,2,3-triol reacting when you have propane 1,2,3 triol reacting with a fatty acid, you will have the fat and oil we are talking about. Don't forget, carbon must join to carbon in whatever you are drawing. Carbon must join to a carbon. So this is propane 1,2,3 triol having 3 hydroxy group. You have a fatty acid reacting with it to give you ester and water. A fatty acid reacting with it to give you your ester and water. Now you can write RCOOH, R prime and R prime prime. It's just to denote the alkyl group. So when these two react, you get your ester, RCOOC2, CH2, RCOOCH2, and you have your RCOOCH2 plus water. So this is you have your ester, you have your water, you have your alkanol here, and you have your fatty acid. So fatty acid commonly found in lipids are long chain alkanoic acid, and they have the general formula RCOOH. They have that general formula. I'd like you to know that we have 2 types of fatty acids. We have saturated fatty acids and we have unsaturated fatty acids. We have saturated fatty acids and unsaturated fatty acids. Saturated fatty acids will have no double bonds in the hydrocarbon chain, while unsaturated fatty acids will have 1 or more double bonds in the hydrocarbon chain. If you recall, alkanes are saturated hydrocarbons. Alkenes and alkynes are unsaturated hydrocarbons, having double and triple bonds respectively in their carbon chain. So I'm going to stop there for today, expecting that we'll talk about hydrogenation of oils when next we meet. But before I round up, let me just let you know some properties of fat and oil. Properties. It depends mainly on the proportion of each constituent. Fats having high melting point will be composed of a higher proportion of esters of saturated fatty acids. But oils, it has lower melting point because they are composed of a higher proportion of unsaturated fatty acids. Please note that fats having high melting point are composed of a higher proportion of esters of saturated fatty acids, while oils, they are having lower melting point because they are composed of a higher proportion of unsaturated fatty acids. So I'm going to stop there for today while we'll talk about hydrogenation of oils when next we meet. Thank you.